if I was not able to download your homework 4, I sent you a note through Canvas this morning. Okay, a little before the 10 o'clock class. So if you did not get a note on Canvas from me saying that I'm missing your homework 4, you can assume homework 4 is good. People say they're missing my audio. I don't know why that would be. Because it looks solid here. Interesting. Huh, okay. Let me poke around my settings here. Alright, testing 1, 2, 3. That's automatically adjusting. Weird. Alright, let me change devices. Built in. LCS. Alright, is that any better? Testing 1, 2, 3. Okay. Cool. Yeah, so how did I fix that? I basically rebooted. It works. Interesting. Yeah, so Zoom is set up to automatically adjust my volume, but the adjustment it had was pretty low, and so I just switched to a different device and switched back, and now the adjustment is really high. Alright, well thank you for letting me know, otherwise I would have been like talking for an hour with nobody hearing. So let me go back to screen sharing, and hopefully that doesn't break anything. Yes, but the real question is, how many times did you reboot? Alright, and that's the definition of insanity, right? That's the old joke about computers, is like doing the same thing and expecting a different result. Alright, so again, homework 4, I've downloaded all the submissions that I could. If I was not able to download your homework 4, I sent you a note on Canvas this morning. So if you didn't get a note from me on Canvas, you should be good to go. If you did get a note, please get in touch with me right now. Send me an email, let me know what's going on. If you want help getting your GitLab repo set up, send me an email right now, and come by office hours at 2. I made a comment yesterday that I was going to have to end class a little bit early today. That was totally bogus, because this meeting that I have scheduled apparently is somewhere down the road, not this week. So we'll have a regular class till 11:50 today. All right. Any questions on homework 4, C programming, stick games, anything else that we've been doing up to this point? I'm always worried it didn't save properly. So again, you can make your repository, as soon as the assignment comes out, and send me an email and say, does this work? And if it works, it'll keep working unless you delete the repository and start over again or something like that. And if you do that, as long as it's not Friday morning at 5 a.m., send me an email. I'll be happy to download your repo and make sure that I have access to it. So the whole GitLab thing is not punitive, right? It's not something I'm doing to try to make people jump through hoops. It's a really nice way for me to be able to download all of your work, and for you to be able to upload, not just your C code, but a README and a makefile and all this other stuff. So I really want that to work well for everybody. And it's something that if you go to WSU, you'll do a lot of, right? Most of the classes there are GitLab focused, so that's a piece of most of the work you'll do up there. Yeah, I can relate to that. All right, so questions, comments? All right. So I did start looking at a bit of the code. I had about 20 minutes this morning to start looking at some of the submissions, and they look great. Okay, I expect people are going to do really well on this. If there's issues, it's probably going to be with handling command line arguments, reading input from the user, dealing with errors in the input, and those things are always kind of tricky, and they vary from one language to another. And it's a part of whatever language you're working in to learn that. If you were back in time using PL1, you'd learn about picture statements, and that's a whole sinkhole of glorious detail. But it's always an aspect, and honestly, doing input in particular in C, not the most obvious intuitive thing in the world. There's a lot of fine-grained detail to worry about, but that's part of why we worry about it in this course, right? So if you're doing this on a job or something, you've at least worked with it before. Let's see, question, do you read the commit messages? Sometimes I do. I mean, I don't judge people for them, but sometimes I like to see how long someone's been working on their assignment based on their first commits. In particular, if somebody is coming to me and saying, that they tried this and they tried that and it didn't work, I might want to go back and see, what they were doing in earlier versions and stuff. So yeah, I might look at those, but they don't affect your grade or anything for sure. And I won't take offense if they're snarky or something. All right, so yeah, I'll grade your assignments over the weekend, and I'll probably make some comments on Monday related to what I see. As far as recurring themes, problems with input, stuff like that. Let's see, question, is there a command you can run that ends the program similar to break? So if you want to end the program, completely get out of the program, there is a function called exit, which you can include from standard lib.h. I dare say it's possibly a little sloppy to use that, because you could be 5 levels down in some function called another function, and all of a sudden your program exits. And from your main program, there's no way to tell that that's happening. But if you want to do that, for the stick program or something, that's certainly fine. But another option is to, if a subroutine decides that the program should exit, percolate that condition back up through return values or flags so that the main program can exit gracefully. Breaks get you out of loops. So if you're looping and you want to kick out of that, a break statement will do it. Continues take you back up to the top of a loop. So, flow control options. Is there one for if statements? Breaking out of an if statement. I used to believe that break statement would do that, but that might have been a dream. So, but I'm trying to think where you would possibly want to do this, because if your break is conditional, right, if you want to break out only if I is equal to 0, well, you just put an if statement in there. If I is not equal to 0, do the stuff that you want to do. And if it's an unconditional break, right, just end your if statement there. So, I'm going to go ahead and post a resource on Canvas. In fact, I'm going to make myself a note. After class, I'll post a resource on Canvas. It's a free PDF download. It's a very short textbook that I wrote last year for this course. It's called I Can See Clearly Now. And it's designed for people who know how to program right, and understand the syntax and the structure of C, but want to get better at it. And it's basically goes over things like if you're writing if then else statements, how can you do it in a way that's less confusing, that's less likely to get you tangled up with do I need another curly bracket here or do I need it there, things like that. It's not required reading. It's not something you're going to be tested on. It's just a resource. Okay, it's something I put together, intending it to be a bridge sort of on the way from CSE121 to CSE222. So something around where you might be, you know, taking this course. I'll put that up on Canvas, and if you want, have a look at it. It's filled with typos. I'll admit that first because I wrote it in a rush last fall. But it's short. It's a pretty quick read, and you might find some of the stuff useful as far as flow control and things like that. So I'll put that up this afternoon. All right. Anything else? All right, cool. Well, my plan then was to try to finish talking about VI today. Okay. I don't want to spend too much time on VI in this course, but it is, you know, an editor that you'll encounter more often than not. And knowing how to use it efficiently will definitely help you. And VI, you know, you can buy entire books on it. We're really scratching the surface, but I just want to give you sort of idea of some of the things you can do in VI. And just knowing that you can do these things, right, if you find yourself wanting these things down the road, you can go back to your notes or the videos or whatever and maybe get some ideas, some things to try. I'm not going to test you on this. I'm not going to give you, you know, what does this command do, what does that command do, and so on. But I can almost guarantee that if you get a little more fluent with VI, it'll make your coding easier. It will make your coding sessions more productive because you can spend more of your time thinking about the code and not thinking about the text editing. So let me see, where did we leave off? Let's just hop into a test file. All right, so here's my my bash RC file. We talked about deleting the other day, right? So you can delete a line with DD, you can delete a character with X, and you can put numbers in front of those. So I can delete 4 characters by saying 4X. I can delete 5 lines by saying 5DD, and so on. And I'm doing a U to undo these, by the way. So when you delete something, it turns out it goes into a clipboard, basically, something called a yank buffer. So if I delete this line with DD, or let's say these 7 lines, so I do 7DD, which gets rid of those lines. Those are things that set up my prompt, right? I can go somewhere else in my file, and if I do a lowercase p, it will paste or put what I deleted into that spot of my file. Alright, so I just moved this chunk of code from the middle of my file to the bottom. And you can also copy code and put it on the buffer by using an uppercase Y for yank. So if I want to grab these 3 lines, I can say 3 uppercase Y, and it tells me 3 lines are yanked. And then I could go up here and I could put this right down here with a P, and it puts my statement right there. So there's a copy paste buffer. Now you can copy paste with your mouse also. Okay, it's less efficient in general. and it becomes second nature. If I want to swap these two lines, I can just do DDP, and it will swap them, right? DD deletes one, and then P puts it below the current line. If I want to swap two characters, I can just do XP. So if I transpose these two, XP swaps them back. So little things like that. And in general, a period repeats your last command. So let's say I said, let's change word alias to my alias, right? So I can come down here, and here's another alias command, and I want to change that to be my alias also. I can just hit a period, and it will repeat my last command, right? Or I could say, you know, 3 period, and it'll repeat my last command 3 times, which doesn't do anything in this case. Actually, it doesn't. Never mind, you can't do that. But you can hit period multiple times. All right. The other command is join. So, let's see, what's a good thing to join? Let's say I want to put this comment at the end of this line. Right, so I want to say umask077, and then on the same line I want this comment which says be secretive. Okay, I can copy and paste and stuff like that. Here's a different approach. I'm going to delete this line with DD, I'm going to put it below this line with P, I'm going to go up with K, and then I'm going to use an uppercase J to join. So J will join the line below you to the end of your current line, and there you go. Alright, so J is useful. And if you are trying to move through your file with a J and your caps lock is accidentally on, and you're not looking at what you're doing and you're hitting Shift J, you end up like turning your whole file into a single line by mistake, and that's no fun, but it kind of is. Let's see, question, when it's okay, can you explain visual mode? No, because I don't know what visual mode is, other than we're kind of in visual mode right here. But yeah, I know what you mean, and I don't know a lot about it. But I will talk about EX.
I can add to what visual mode is. It's basically like a selection. So it's like highlighting text is what visual mode is.
Oh, okay. Cool.
Yep.
Alright, in main I made gotos to essentially act like breaks. Ooh, we got code with gotos in it. Cool. I like gotos. I won't take off points for gotos, but I will put comments saying I don't recommend doing this. Breaks are really gotos. Alright, so, alright, so let's talk about searching. Yeah, gotos. So I don't know if we've talked about gotos in here or not. You know, gotos are a thing, and in assembly language, you use branches or gotos all the time. In machine code, you use gotos or branches all the time. It's this thing that happened in the 80s with structured programming where people decided, you know, we should not use gotos. And there was a famous book called Gotos Considered Harmful, right? And people made fun of it, but the people who hire the people who made fun of that, you know, came up with these decrees that you need to use structured programming. And so we try not to write gotos and stay in code, and a lot of languages don't even support gotos anymore. They can be used in a way that is appropriate, just like global variables can be used in ways that are appropriate. But you know, if you're at a job interview and you use a goto statement, the interview's probably over. And if you're new on a team and you write code and you've got gotos in there, probably going to get called into your boss's office. It's just such a knee-jerk reaction sometimes. But you know, a break statement is really a goto. It's saying, okay, I don't care about this loop I'm in, I just want to jump unconditionally to this place outside of the loop, right? A continue is a go-to statement, and really an if-then-else is a go-to statement. But those constructs are more constrained, right? So that's the reason we tell people not to use go-tos. All right, so searching. Let's say I want to search for the word alias. If I say /alias, it will move me down to the next spot in my file where that pattern appears, which is right here. If I say /alias, it'll move me to the next spot where it appears. I can also just hit a lowercase n, and that will automatically take me to the next occurrence of alias. And if I get to the last occurrence and I hit n again, it will wrap around and it'll tell me down here, search at the bottom, continue to top. Now if I want to search in the reverse direction, I can do $alias, and that'll move me up. And again, I'm using a lowercase n to keep searching to repeat my last search. If I do an uppercase n, it reverses the direction. So I used a question mark to search up, an uppercase n will search down. And if I do a slash to search down, an uppercase n will search up. That's not something you're going to, like, you know, spend a weekend trying to memorize, but, you know, throw it down on a piece of paper somewhere and you're trying to search for something in your file, pull up this idea, oh yeah, I can do slash and I can search for, you know, whatever it is I'm looking for, and it takes me right there. And if that's not the one I wanted, I can do n and move around. Let's see, what made people dislike them? Go-tos. So the concern with go-tos, I think I talked about this in the A section, but not in the B section. The concern was, you know, you write a piece of program and there's usually some initialization, there's some processing, and there's some finishing. And your processing, you know, usually has some stuff and some loops and some conditionals and so on. And you write this code and it works great. It's a billing program for the gas company, right? And it works great. And, you know, it's 1965. And 5 years later, there's a new billing algorithm, and somebody needs to update this code, and the person who wrote it has left. And so somebody else gets this code, and they're told, you know, you have to check for this special condition, and based on that, do one thing or do another thing. Well, they don't want to monkey with this code too much, because this is 1,000 lines of Fortran 4, or COBOL. And they just want to make this one change, right? Before you figure out the billing rate, they want to know if your customer ID begins with the letter X. And if it does, you get a special rate. So they write a new section of code which says, you know, if the billing rate is such and such, do this. And then in here they say go to that. And at the end they say go back. Right? And some early languages, your code had line numbers on them. And if you needed to do something between lines 57 and 58, right, you were kind of out of luck. So you would change 57 to be a go-to somewhere else, do your new stuff, and then go to 58. So this works for another few years, and then somebody decides there has to be some extra condition in here, so this branches over to somewhere else, does some stuff, branches back. And then someone says, oh, but in some cases this shouldn't branch back there, it should branch all the way back here. And then somebody says, yeah, but under this condition we shouldn't do any of this stuff, so here we're going to branch down here. And so, yeah, what somebody said, you get spaghetti code, where you just have all these lines of execution wrapped around each other, and it's really, really hard to tell how did I get to this piece of code, and where does this piece of code go? And so people did, you know, studies and came up with these great statistics like, you know, 90% of the cost of a piece of program is spent on maintenance. 10% is spent writing it. And the other is all maintaining it. And so as code became a bigger part of what companies did and where their money went, people became concerned with how do we manage this, you know, unmanageable code across time. And so people started practicing structured programming, where you would use these very controlled ways to change your execution flow, either a loop or an if statement. One anecdote I heard in the 80s when I was first learning this stuff in school, somebody did an interview with a blind programmer. Okay, this person could not see, but they were a coder, and they were a very successful coder. And somebody asked them, how do you code when you can't see the code with your eyes? And he said, I have somebody read it to me. And this person would read the code to them, and they could, edit it and make changes and find bugs, and they could write code, and then when it needed to be edited, someone would read it back to them, and so on and so forth. And the person asked, the interviewer asked, well, what's the longest program you've worked on like this? And he said, about 10,000 lines of code. And this was fascinating. This person who can't actually see the code with their eyes could work on a 10,000 line program just by having somebody read the code to them. And he said, yeah, but there's one caveat. If the code ever jumps to a section that I haven't already had read to me, I can't work with it. It can only jump back to previous sections of code. And that's more or less what happens with structured programs, right? You go back to earlier code in a for loop or a while loop. So that's a bit of the idea of avoiding gotos and avoiding spaghetti code. But then, when it comes down to it and you got 5 seconds to finish something, sometimes everything goes crazy anyway. All right, so searching. All right, so let me show you things we can do from the command line in VI with typos. So when you want to exit your program, you can say colon, and you can type different things here. You can say Q to quit, you can say W to write, you can say X to write and exit, you can say Q exclamation mark to quit even though you made changes, and so on. But this colon, this command line, unleashes a whole bunch of features inside VI. So one feature is I can say colon exclamation mark, and I can type a Unix command like date, and it'll run the date command and show me, oh, it's 11:30 right now. And then when I hit enter, it takes me back to where I was in VI. So I want to know what files I have in here. I can say colon exclamation mark ls, and it shows me the result of running the ls command. And then when I'm done, I hit enter, and I'm back in my editor. All right, so what do I got in here? I don't know. Let me make myself a file. Actually, let me do this. So let's say I'm editing my program, and I decide I want to make a README, right? I can say colon VI, and I can switch to another file, README, and I can start writing this. And if I want to switch back to the previous file, I can do a Control-6. Control-6 alternates between the last 2 files that you've edited. So I can come in here, I can get rid of that typo character, write that out, go back to my main program. Right, and so there I can see a list of my files. I can do lslrt and see the README is that last file that I just created, and so on. And if I decided I wanted to include that README file in the top of this script, what can I do? Well, I'll open up a new line with a Shift-O, then I'll do :R space and the name of the file, and that will read the contents of that file and pull it in to my current file right where my cursor is. Right? So if I have a file that I want to include in another file, I can do that. So here's something that I might do. Maybe I like making a header file. And this is kind of slow and painful. Alright, well I want to include that in the top of my program, right? I can say :read header. Let me open a new line, right? And I can just pull that in the top of my file. And then I can go ahead and edit. So if you have like, you know, sort of a standard comment block that you like putting in the beginning of your C code, right? You can throw it in a file, you can pull it into whatever file you're editing, and then, you know, tweak it as you need and so on and so forth. So :R will read the contents of a file into your current location. Let's say I want to know when I'm making this file. I can say :R exclamation mark and type a command, like date, for example. And this will say execute the date command, take the result of that command, and read that into my file at my current location. So read exclamation mark date, executes the date command, pulls it in. I can come up here and join it, and now I've got a date stamp. If I don't remember who I am, I can say written by, I can say read who am I. It pulls in my username, and now I can say written by Nick. If I want to know where it is in the file system, I can say read exclamation mark print working directory, right? So you can incorporate Unix commands and capture their output and throw those into your file, and that can be useful. And yeah, you can make, you know, a quick file. Right, so maybe this is something I always want in the beginning of my code. So I'm just going to call that file A. So let's make homework 006.c. First thing I do is read A, and bang, there's the start of my code. So yeah, you don't ever have to type include standard IO again if you don't want to. All right, command line, other things you can do. I can say substitute /root/nick/. So :S means on the current line I want to do a substitution. If I find the word root, I want to replace it with the word Nick. Okay, I'm sitting on this line right here, so this should change that occurrence of root to Nick. Alright, and this is a really powerful operator, because I just did a really simple example where I changed this four-letter word to the word Nick. But we can use what are called regular expressions and do all kinds of processing and powerful substitution on this command line. If I wanted to change the word alias to the uppercase alias, everywhere in my file I could say $1, $. 1 is the first line of the file, $sign is always the last line of the file. So this says, for every line of my file, change the word alias to the uppercase word alias. And it tells me it did that 10 times on 10 lines, and all my aliases got changed to uppercase. We can also delete things. Let's say I want to get rid of these 3 lines. I can say between the current line and the current line plus 2, delete. And it gets rid of those 3 lines. Alright, so we're going to play around with a utility at the end of this course called SED, S-E-D. SED is a stream editor. It's a way to do some of these things I'm showing you right now, like these substitutions, without having to go into VI and type. It will let us make a script which says, here's the changes I want you to make on this file. And we run that script through SED and we give it a file, and it will apply all of those edits for us. And this is really useful, right? Because we can run a Linux command, we can take the output and we can capture it in a file, and then we can manipulate that file using things like SED. And in fact, we don't even have to put it in a file, we can pipe it directly into SED using a pipe, and then take the output and process that. And all the tools that I have running in the background for my teaching, the stuff that's grabbing screenshots of the participant list, the stuff that's time stamping, the video recording and so on and so forth, that's all just, you know, scripts using SED and awk and all these other utilities that we're going to talk about, probably more towards the end of the quarter. But they're largely extensions of things that you already have available in VI. All right, so you know, you could do a 10-week course just on VI and still not really get very far below the surface. So this is just, you know, some things to keep in mind, just some things to be aware of that are possible in this editor. And like I say, just sort of keep them handy. And, you know, if you're constantly like hunting and pecking, moving line by line, looking for something, pull up the slash command, right? Oh yeah, I can say slash something and search for it. And, you know, if you do that 5 or 6 times and it turns out to be really useful, you'll probably start using it more. Will the midterm be a timed assessment or something different? Midterm will be an online quiz during class, so it'll be 50 minutes, and it'll be during class time. And I gotta figure out when that is. It might be next week. I gotta check Canvas. All right, total change of gears now. So let's talk about writing C code and splitting it into pieces. Okay, so let me make a sample main program. So let's see. So what do I want my main program to do? So I'm going to print out some elaborate greeting, but I'm just going to do one line for now. Welcome to my program. We'll print that out 4 times. And then let's read a number from the user. So we'll ask the user to enter a number. We'll read a number. Alright, so we'll get a number from the user. And let me go ahead and make some variables. So we'll ask the user for a number. We'll use fgets to read in a buffer. We'll try to scan it as an integer into I. If it doesn't scan successfully, we'll say try again. And then we'll go ahead and print out the square of that number. So there's a kind of silly program, but let's see what this does. So enter a number, haha, bad number, try again, enter bad number, try again. Okay, 7, square of 7 is 49. Cool, it works, okay? So, yeah, don't forget your new lines. So imagine that, this file is a lot longer, right? You've got thousands of lines of code, and it's all kind of convoluted and confusing and so on. So this is where I talk about modularizing, okay? Breaking this thing up into logical pieces. Modularizing, spelled wrong. So we can make a series of functions. So I'm going to take these first 4 lines and I'm going to put them into a separate function. I'm going to call this function greeting. Is there a printf equivalent that also new lines? Not that I know of, but you could write one. Alright, so I'm going to change that set of print statements to just a function call called greeting. Alright, and then this stuff, I'm going to move into a new function, which is going to prompt the user, get in line, parse it, and return an integer. So this is going to be integer get num, and it's going to do all of this stuff. And it's going to return whatever that value of I was. And then I'm going to take this, and I'm just going to call it so I'll call getNum, and then I'm going to change this print statement, which again, imagine it's very complex. I'm going to call it print result. Alright, so there's a print result function, and I'm just going to call that in here. I'm going to pass I to it. Alright, so what have we done here? We've broken this into functions. We have failed to prototype our functions. I failed to prototype my functions. So let me do that. Void greeting doesn't take any arguments, doesn't return anything. Integer getNum doesn't take anything, returns an integer. And print result takes an integer. And I'm missing a bracket somewhere, but we'll figure that out. Alright, GCC line 12 expected a semicolon before. Alright, let's go back in. I'm going to do a 12 uppercase G, and that usually brings you close to where your error is. Alright, so I can run my program. If it's a bad number, it'll tell me. If I put in a valid number, it'll print out the square. Alright, so this does the same thing as our original program. But here's the thing, our main program is pure simplicity. Okay? It's really easy to see what's going on in my main program. I'm printing out a greeting, I'm getting a number, I'm printing a result. And so now if my goal is to do this until the person inputs the number 0, I can do the following. Right? And now my program will repeatedly ask me for a number. If I put in something different than 0, it'll print out the square. It'll ask me for another number. And if I tried to do this on that original piece of code, it's a little more complex. And I probably get lazy and I stop indenting my code carefully, and I'm going to mess up my curly bracket and so on and so forth, right? And this is still fairly clean, right? I'm not going to have any trouble debugging this. I'm going to throw in some spacing, right? So I know the greeting happens separately and that this is the main loop, and go from there. Now, if this gets too much more complex, I might make a new function, right, called, you know, process loop or something, and throw all of that in there, and then after the greeting I would call process loop, and then I'd do something else. Alright, so we only have 38 seconds left, but the next piece of this is trying to take this and split it into separate files. Okay, so instead of having all of this inside one file called main.c, what I'm going to do is I'm going to make a main.c, I'm going to make another file called greeting.c, and then maybe another file called you know, get and print.c that'll include these two functions. And I'm going to have a bunch of .c files, and then we're going to want to compile those separately and link them together. Okay, and if you're looking ahead, this is leading to being able to work with something called makefiles, and that's what I want to talk about Monday. Let's see, last question. Have to compile my program every time and figure out how to access stuff outside my current directory. So I can leave it in my main folder, but it doesn't print out the last number. Yeah, so, and other languages work better as far as, you know, if you want to override what some function does, we can do that. But there's tricks you could use to make it pretty painless to define your own print function. And you can make a macro, and you could, if you're on your own system, you could put it inside your own standard io.h. Don't tell anyone I said that, though. All right, we are out of time. We will dig further into this example on Monday. We will split this into pieces, and we'll talk about makefiles, which is a nice systematic way we can put pieces of a file together and write a script or a recipe for that. All right, have a good weekend if I don't see you in 2:15. Otherwise, I'll see you in a half hour. Thank you.